Welcome, this is Coach Dorf. Let's look at a homework example from section 1.1. So in this example, we're going to be talking about odd and even functions. Odd function is defined to be if I put in f of negative x, I get negative of f of x back. An even function is if I put in f of negative x for x, I get the original function f of x back. So let's go into this a little bit more depth. Why is it called an odd function, first of all? Well, an example of this is the function f of x equals x cubed. Notice that on this one here, the exponent is odd, equals 3, which is odd, meaning it's an odd number, not because it's weird, but just because it's an odd number. And what's the graph of that look like? Well, this is one of those that I asked you to memorize. The graph of f of x equals x cubed looks like this. If I put in negative x here for x, what does that mean? That means I'm going to put parentheses negative x, close parentheses, cubed. So wherever I had in my original function, we had x there, we have x here. So now we have negative x there, we have to put in negative x. But remember, we're always going to use parentheses so that we don't make mistakes. What does negative x cubed mean? It means negative x times negative x times negative x. And I have 3 negatives, which means those would turn out to be 1 negative, equivalent to it. And I have an x cubed. So f of negative x equals negative x cubed. What's f of x? It was x cubed. So negative of f of x is negative x cubed. Well, that was really not so good. But anyway, that is the same thing as this. These two are equal. So f of negative x equals negative f of x. And that means f of x is odd. It's an odd function. Another way to tell an odd function is by its graph. So the graph of an odd function is rotated about the origin. What does that mean? If I have a function that looks like this, and suppose my function in the first quadrant, it looks like that. If I rotate that around the origin, that means I'm going to take that orange part and rotate it 180 degrees, 180 degrees. And so then I'm going to end up with something that looks like this. That tells me that this is an odd function, or the graph of an odd function. That's an odd function. What's an even function? We have an example of that is f of x equals x squared. Notice my power here is 2, so the exponent equals 2, and 2 is even. That doesn't mean that anytime you have a square or an even power on a variable, that it's going to be an even function. Or if you have an odd exponent on a function, it doesn't mean it's not going to be an odd one. But these are two examples to remember. If you want to remember an even function, remember x squared. If you want to remember an odd function, x cubed is an easy one to remember. Why is that an even function? So remember, even gives us that f of negative x equals f of x. So for f of x equaling x squared, f of negative x is going to be negative x squared. Again, remember, notice here, I've got a parentheses here, and I'm going to do that each time. That means it's a negative x times a negative x, which is x squared because the two negatives cancel each other out. And that is f of x. F of negative x equals f of x for f of x equals x squared. And that means that f of x equals x squared is an even function. And what's the graph of f of x squared look like? It is the parabola. And what happens here for even functions, the graph is symmetric about the y-axis. And what does that mean? So if I have a function that looks, I think I did something like this on the first one, if it's symmetric about the y-axis, then it's going to be something that looks like this. I have a mirror for the part in the right half part of it. If I just flip that over on a page, I get the blue. So if I flip the orange colored curve about that vertical line, I get the blue curve. And we see that that's what happens here with x squared. If I take this part, that orange part on the parabola, and I flip that over this vertical axis, I get the green part there. So that's what odd and even functions are. And a function is neither if it is not odd and not even. So in this particular problem, we were supposed to look at f of x equaling 3x squared over x squared plus 1. So this even, odd, or neither. So the first thing I would do is I'm going to look at f of negative x. So I'm going to substitute in negative x for anywhere I see x in the formula for the function. So I'm going to get 3 times parentheses negative x squared over negative x quantity squared plus 1. So I've put in negative x inside those parentheses. What is negative x squared? We did that earlier, but let me do it again. It's negative x times negative x. The two negatives cancel each other out, and I just get x squared. So in this case, I'm going to get 3x squared over x squared plus 1. Now that's the same thing as what we started with. This is equal to that. So that means this is equal to f of x. So we have f of negative x equals f of x, and that means f of x is even. So let's just say we graph f of x equals 3x squared over x squared plus 1. Well, it's not one that we've talked about. So I would suggest check out a program called Desmos online, and it will help you graph function. So you can work with that to do that. If I go onto Desmos and graph this function here, it's going to look something like this. This is what f of x equals 3x squared over x squared plus 1. I can see that it's reasonable that if I take this green part, and if I take that green part and I flip it over onto the left side, so the part that's on the right side, if I flip it over the vertical axis, the x-axis, I'm going to get the blue part. And so this graph demonstrates that f of x is an even function. Let me just end up with one last thing. What's an example of a function that's neither odd nor even? Let's say f of x equals 1 over x minus 1. If I do negative x in here, that means I'm going to look at the function at negative x. That means I'm going to do negative x inside for x here. So again, what I'm doing is I'm taking negative x, I put it in there, I keep my parentheses in there. When I simplify that, I'm going to get 1 over negative x minus 1. Now, what could be done here is I could multiply top and bottom by -1. I'm multiplying the top and bottom by the same number, so it doesn't change the value of the function. And the reason I may want to do that is because the denominator has a bunch of negatives, and maybe I want to change that. And this is probably, if you were to check your answer in the back of the book, then this is what you would probably see. Perfectly fine to check your answer in the back of the book, but do that after you do the problem. When I multiply these together, in the numerator, I have 1 times -1, so I have -1. And in the bottom, I have this -1, and it gets multiplied by everything in the bottom. So -1 times x is going to give me a positive x, and -1 times -1 is going to give me positive 1. So how does that compare to f of x? Well, this and this, they're not equal to each other. They can't be equal to each other. And so we know that f of negative x doesn't equal f of x. And if I were to multiply f of x by a negative x, they're still not equal to each other. So that's a function that is neither. Hope that helps. Have a good day.